Hey everyone, welcome back to Context Window. For today's Masterclass Explainer, we aren't just talking theory. We are walking through the actual 2026 tech stack you need to master to build the future of intelligence. I am absolutely thrilled you're here, so let's get right to it.
Here's the blueprint for our workshop today. We'll cover the 2026 bifurcated landscape, the core layer of code, frameworks and models, the fuel layer of data, pipelines and training, the engine of deployment and cloud, control via orchestration and evaluation, and finally, the decision matrix.
Section 1. The 2026 bifurcated landscape. Let's look at the big picture of where the industry is heading. The real deal is that intelligence is no longer just a bolted-on feature, right? It's literally the core nervous system of enterprise architecture, and that's creating two incredibly distinct professional paths. If you're on the AI path, you are the director of intelligence, orchestrating pre-trained systems and building agentic systems directly into the product layer. But if you're building the foundations as an ML engineer, you are the architect of foundations, deeply optimizing low-level models and handling the hardware alignment.
Moving to Section 2, Core, Code, Frameworks, Models. Let's dive right into the core of our tech stack, the actual medium of communication between you and the machine.
Step 1. Programming languages. Think of this layer as the nervous system of your daily workflow. If you're on the AI path, you're looking at Python, TypeScript, SQL, and Bash. You need Python for its vast wrappers and SDKs, TypeScript for rendering AI-driven interfaces, SQL for querying massive data logs, and Bash for automating your microservices. But if you're building the foundations as an ML engineer, you'll still need Python, but you'll be deep in R, Java, Scala, and C++. You need R for specialized statistical modeling, Java and Scala for high-throughput data processing, and C++ specifically for writing custom kernels that interface with GPU hardware. Now here is the pro-level jugad you need to know for 2026, Mojo. Mojo is our wildcard here, delivering bare metal C++ speed, but using a Python-like syntax, making it a massive strategic asset for writing systems-level code for AI workloads. Step 2 is frameworks and libraries. On the AI path, you're looking at LangChain, LlamaIndex, the OpenAI SDK, CrewAI, AutoGen, and Hugging Face transformers. You'll use LangChain and LlamaIndex for chaining calls and bridging private data, the OpenAI SDK as your standard for frontier models, CrewAI and AutoGen for multi-agent collaboration, and Hugging Face transformers to access open-source models. Now, if you're an ML engineer, you'll be deep in TensorFlow, PyTorch, Scikit-learn, XGBoost, and LightGBM. You need TensorFlow and PyTorch for large-scale training and prototyping, plus Scikit-learn, XGBoost, and LightGBM for robust, tabular data classification. The game changer across the board? PydanticAI. This is the wildcard framework, enforcing strict, type-safe schema validation, ensuring your agentic outputs are structurally correct before entering your application logic. Step 3. Model usage. For the AI path, you're looking at frontier models like GPT 5.4, Claude 4.5, and Gemini 3.1 Pro, alongside open-weight models like Llama 4, Mistral 3, and Qwen 3. You'll leverage the frontier APIs for massive compute use and coding tasks, and the open-weight models for privacy-centric, local deployments. But if you're an ML engineer, you'll be deep in specialized ML architectures using custom CNNs and RNNs. You'll build those custom CNNs for vision and RNNs for time series analysis. The wild card to watch here is liquid neural networks, or LNNs. They dynamically adapt their continuous time differential equations on the fly based on input, which is absolutely crucial for letting tiny models process video streams efficiently on edge hardware.
Section 3. Fuel, Data, Pipelines, Training. Moving up the stack, let's explore exactly how data is handled and transformed into intelligence.
Step 4. Data handling. This layer is critical. If you're on the AI path, you're looking at Pinecone and Weaviate. You'll use these vector databases to manage semantic search and store high-dimensional embeddings. But if you're an ML engineer, you'll be deep in pandas and NumPy, cleaning and normalizing numerical layers to build high-quality tensors. The one to watch here is TurboQuant KV cache compression. This wildcard uses specialized quantization to compress the key value cache during inference, totally solving that massive quadratic memory overhead problem when processing incredibly long conversations.
Step 5. Data processing and pipelines. Think of this as the industrial conveyor of our stack. On the AI path, you're looking at fast API and event-driven workflows to trigger real-time document ingestion and context injection. But as an ML engineer, you'll be deep in Apache Spark and Airflow. You need Apache Spark for distributed cluster processing, and Airflow for orchestrating complex batch and streaming pipelines. And here is the pro-level Jagad, SkyPilot. It's our wildcard acting as a unified interface for Sky computing. It automatically finds the cheapest GPU clusters across AWS, GCP, and Azure, severely slashing your cross-cloud hardware costs.
Step 6. Model training. For the AI path, you're looking at fine-tuning APIs, RAG, and few-shot learning. You use these to guide model behavior without doing permanent, expensive weight changes from scratch. If you're an ML engineer, you'll be deep in hyperparameter tuning and cluster training to deeply optimize batch sizes and learning rates on high-performance GPUs. The radical wildcard trend here is BitNet 1.58b. It runs 1-bit models using weights of just -1, 0, and 1, performing massive mathematical operations with pure addition and subtraction. It's a game changer for energy efficiency on standard CPUs.
Section 4. Engine, Deployment, and Cloud. Now we decide exactly how and where these intelligent systems are hosted to serve real users. Step 7. Deployment. On the AI path, you're looking at FastAPI, Vercel, and AWS Lambda to build API-first serverless logic and optimize cold start times. But if you're an ML engineer, you'll be deep in Docker, Kubernetes, TorchServe, and TensorFlow serving. You'll use Docker and Kubernetes to isolate models, and TorchServe and TensorFlow serving to handle high-throughput, real-time inference. Here is the game changer, Modal AI. This wildcard is a serverless GPU platform where you define compute requirements in Python scripts and it automatically scales bursty workloads from massive compute down to zero instantly.
Step 8 is cloud platforms. If you're on the AI path, you're looking at the OpenAI API, Anthropic API, Azure OpenAI, Google Vertex AI, and AWS Bedrock to easily access frontier models with built-in grounding. But if you're building foundations as an ML engineer, you'll be deep in AWS SageMaker, Google AI Platform, Azure ML, and Databricks for totally custom model management lifecycles. The real deal here, our wildcard, is scoring NVIDIA B200 Blackwell clusters. With 192 gigs of VRAM and massive NVLink bandwidth, you strictly need this hardware to bypass the severe memory wall when training 100 billion parameter models.
Section 5. Control, Orchestration, and Evaluation. In our final technical layer, this is how we stitch it all together and verify it actually works in production.
Step 9. Orchestration. To keep chaos at bay on the AI path, you're looking at LangGraph, CrewAI, AutoGen, NN, and Make. You need these to dictate agent state, manage team delegation, and visually connect workflows. But if you're an ML engineer, you'll be deep in Airflow, KubeFlow, MLflow, and PEFT to manage complex data dependencies and Kubernetes native ML lifecycles. Our wildcard flight recorder is LangFuse open source tracing. It captures every single state change and model call in multi-step loops, making debugging those tricky agentic failures actually possible.
Step 10, monitoring and evaluation. You literally can't deploy without algorithmic rigor. If you're on the AI path, you're looking at inference layer and model metrics using Lang-Smith and weights and biases to evaluate for hallucinations. If you're an ML engineer, you'll be deep in MLflow, tracking data health and model drift over time. The wildcard here is the Ragas diagnostic framework. It's a suite of reference-free metrics that evaluates context precision, faithfulness, and relevancy, catching silent retrieval failures without needing expensive human-annotated data.
Step 11. Version control and collaboration. This wraps our entire stack. On the AI path, you're looking at GitHub, prompt management platforms, and Notion to trace your code, iterate instructions, and store human constraints. But if you're an ML engineer, you'll be deep in Git, MLflow, and DVC for perfect, absolute reproducibility of model weights and massive datasets. The wildcard replacing static documentation is the LLM Wiki Personal Knowledge System. It's a living context layer that your AI agents can search natively to truly understand team constraints.
Section 6. The Decision Matrix. Having mapped the whole 2026 architecture, let's synthesize this into a career decision to future-proof your trajectory.
Here's the crucial strategic tip. Whatever path you pick, you are going to face massive bottlenecks. As an AI engineer, you absolutely must ruthlessly optimize against context rot. That's the degradation that happens when your prompt windows fill up with totally irrelevant noise. And as an ML engineer, you are up against the memory wall, the physical hardware bottleneck of your clusters communicating across massive parameter scales.
So you have to decide, are you going to be the director of intelligence, an AI engineer orchestrating pre-trained models, products, and agents for immediate real-world impact? Or are you the architect of foundations, an ML engineer deep in the deep learning theory, hardware optimization, and custom algorithms that make the AI world possible in the first place?
That wraps up our 2026 Roadmap Explainer. Whether you're building with models or building the models themselves, the goal is the exact same: agentic reliability. I've added the links to the research, frameworks, and specific resources from this roadmap in the description below. We're building this for the creators and engineers in India and beyond. So, what's one tool from this list you're going to master first? Drop a comment below. I'm personally replying to the most insightful ones. See you in the next one.